So today we are going to cover traffic management policies. Okay, so under traffic management policy, we have CAS policy. Okay, so first of all, what is CAS? Okay, so CAS means when we send a request, okay, it reaches to the backend, and while sending the response back to the client, we store the response inside a CAS. So we have CAS store. Okay. So if we search for the documentation, okay, CAS store size in Apigee. So we can it restrict to 256 KB. Okay, we can restrict 256 KB size in CAS. So here you can see Apigee provides the ability to store data in a cache at runtime for persistence and faster retrieval. So how it will return a faster response? So we can apply the cache policy at the pre-flow, okay, and automatically it will added in the response post-flow. That means when we'll send the request, it will reach to the backend and return the response from the backend. While sending the response data will be stored in the cache store, okay, in the response cache policy, and send back the response to the client. So next time when you will send the same request, let's say there are a student database, and first time you are searching for student whose ID is 1. Okay, you are looking for the details of the student's name, first name, last name, address, etc. So second time when you are calling the same request, let's say you are sending whose ID is equal to 1. So it will not go to the backend directly. First it will check into the cache store whether it is present or not. Okay, that means in the cache store the response is present or not. If it is present, it will return the response from the cache itself. So what happens in this case? The requester doesn't go to no need to go to the backend, fetch the data from the backend and return the response from the backend, right? So in this case, it can search in the cache policy and return the response back to the client. So our response time will be less in this case, and API performance will be high because response time is less. That means whole API performance will be increased. Now, coming to this part, the data is initially stored in the message processors in memory cache. Okay. This is referred to as L1 cache. The L1 cache is limited by the amount of memory reserved for it as a percentage of JVM rule. The cache entries are later persisted in L2 caches, which is accessible to all message processors. Okay. More details can be found in the section below. Now, what it is saying, the L2 cache does not have any hard limit on the number of cache entries. However, the maximum size of the entry that can be cached is restricted to 256 KB. So that means we can, at most, we can store 256 KB data inside a cache. The cache size of 256 KB is the recommended size for optimal performance. Now, now what it is saying, see, this particular anti-pattern talks about the implications of exceeding the current cache size restriction within Apigee. So now if the cache size is exceeds 256 KB, what will happen? So when data greater than 256 KB cache, the consequences are follows. API request executed for the first time on each of the message processor need to get the data independently from the original source, as entries greater than 256 are not available in the L2 cache. Okay, storing large data greater than 256 KB in L1 cache tends to put more stress on the platform resource. It results in the L1 cache memory being filled up faster and hence lesser space being available for other data. So what we mean by L1 cache? L1 cache is the message processor, okay, in memory cache. We have inside the message processor, we have some in memory cache. Okay, some volatile memory. That means once you send it, it will not store for long time. Okay, so being available, if you send more than 56 KB data, then I mean, our in-memory cache have some lesser space being available for the other data. As a consequences, one will not be able to cache the data as aggressively as one would like to. Okay. So cache entries from the message processor will be removed when the limit of on the number of entries is reached. This causes the data to be fetched from the original source again on the respective message processor. Okay, so here you can see some diagram. We can go through it. One moment. Yeah. So what is the best practices then? So it is preferred to store data size of less than 256 KB in cache to get optimum performance. Okay. If there is a need to store greater than 256 KB, then consider using any appropriate database for storing large data. So if you want to store more than 256 KB data, then you have to use some database. Okay. Or compress the data. That's it from cache policy. Now coming to the lab part, okay, lab session. So how to implement it, okay, in APG. Oh, yeah. So here, let me open a cache policy. So we have multiple cache policies. We are going to implement first sample response cache policy. Okay. So how to store a response from the backend. See here, I have created one proxy already. Let me create it from the scratch, otherwise you won't be able to understand. So I'm going to create a new proxy. Okay, let's create a new proxy. um, Reverse proxy sample cache, simple cache v3. Okay, so I'm going to create a sample cache slash v3 as sample cache, and the target endpoint is http bin.org/get. Okay, click on next, secure, deploy it in test, create and deploy. Okay, so we have deployed successfully. Go to edit proxy, go to develop. Okay, so now let me call this API first, okay, without adding any cache policy. So here I have copied this and open Postman. Open it. Yeah, yeah. So let me send this. We got 200. Okay, success response, right? Go to trace. Here you can see 131 milliseconds. The response time. Okay, this total response time is 131 milliseconds. That means here you can see the bubble. Request received from client, request sent to target server. That means this request is sending to the target server. Here you can see this is target server. Response received from target server. So once you see this logo, that means it is reaching to the target server, and response is returning from the target server. Okay, response received from the target server, and the final response is sent back to the client. This is the complete flow, and the response time I can see 131 milliseconds. Okay, now let's add a response cache policy. Okay, So here you can see we have already added one response cache policy for the other API. Let me explain it. So we have cache key fragment, okay, reference request.uri. That means based on what you want to cache the request. Okay, you want to store the response based on what? So based on request URI, that means this is called request URI. Okay, this complete URL is called request URI. Okay, so based on the request URI, I want to store the cache. That means whatever I'm going to pass it, whatever I'm going to send it into the request, based on that, I want to store the cache, okay, cache entry. That means next time if I need to take the response from the cache, then I have to send the same request. So this is my request URI. If you change a single character in this request, you won't be able to see the response from the cache. The request will reach to the backend again. That is the thing. So if you are putting key fragment reference as request URI, you have to capture the cache response based on the request URI only. Okay, so we will see what are the other key fragment we have. Okay, type is string, scope exclusive, then that means this will in entire organizations. Expiry settings, we don't have any expiry settings. Timeouts in second, sorry, expiry settings, under expiry settings we have timeout. That means after this 3600 milliseconds, this cache policy will be timed out, and you if you send a request after this time, the request will reach to the backend again and return the response from there. Okay, that's it. Okay, now go to develop. Here uh, here we have the proxy. Go to develop, go to preflow, and in the preflow I'm going to add this response cache policy. So once I add this target endpoint default, okay, once I add this, it will automatically add it into the target endpoint post flow. See, I have not added this. This is automatically coming because when we send the request, the response will going back from this and it will store the response here. So go to the pre-flow and check the policy, the default policy only. I am not going to change anything. This is my default policy. So it is based on the request URI. It will store the response. Now save this and now now let me start the trace and copy this URL. Go to Postman. Let's say I'm sending ID is equal to 1. Okay, so this is my request URI. This complete is called request URI. Send a request. So I'm sending one query parameter ID is equal to 1. That's it. Go to trace. Go to trace. Okay, here it is. You can see 518 milliseconds. The response time is 518 milliseconds. Here you can see the request sent from the client. Here you can see the response cache policy. Okay, and inside the response cache you can see cache miss it is showing because this is the first time I'm sending the request. And what is the cache key and what is the cache count, all those configuration settings it is showing. And here you can see it is reached to the backend and returning the response from the target server while sending back the target back the response from the target server. It is assigning the response in this policy into this response cache policy. Okay, here you can see cache means, okay, because it is not it is checking into the, it is first time we are sending the request, it is not checking into the cache. Okay, now let me check 518 milliseconds. Okay, this is the response time, total response time. Now send this same request URI again. Okay, I sent it and let's see what happens. What is the change? This is my request. See, 32 milliseconds. Okay, so it from 518 milliseconds to 32 milliseconds is a huge difference. So our proxy performance will be high and response time will be less. Okay, so here you can see I have sent this this response cache policy, and it is not reaching to the backend. See here it was reaching to the backend. In the first call it was reaching to the backend, but into the second call it is not reaching to the backend. Okay, where from where it is capturing, it is returning the response from this cache policy, from the response cache policy. See, um, this cache is executed one. um, so we can see cache hit and it is executed once. Okay, and we can see the response from the cache policy. So the same response it is returning here. Now we saw that our response time is getting less. Okay, 32 milliseconds now. Now let me change the URI, request URI. Instead of one, let me send two. Okay, so let's see what happens. So I have sent it. Now go to trace again and check what happens. See, again it's 367 milliseconds because it is reaching to the backend again. Okay, we have not sent the same. So it is reaching to the backend again. Now go there and send the same request URI. You will see 28 milliseconds again. Okay, it downs now. So like that way this cache policy works. Okay. So using cache policy mm, uh, we can minimize the response time and maximize the proxy performance. That's it. Now coming to this lookup cache, populate cache, invalidate cache. Okay, so this invalidate cache. Okay, invalidate cache means we can delete something. Okay, see, invalidate cache. So here you can see invalidate cache policy configures how the cached values should be purged from the cache. Okay, this my system will restart at 12 10 9. So configures how the cached values should be purged. Okay, from the cache. This policy is intended for use in general purpose short-term caching. So this is short-term caching. It is used in conjunction with the populate cache policy and lookup cache policy. For caching the response of backend resources, if you want to clear the cache outside of a message flow without policies, you can use clear a cache entry management API. Otherwise, if you want to delete the cache entry, you can use this invalidate cache. Okay. Let's see how to do that. Okay. Okay, first go one by one. Go to populate cache first. Okay. So configures how cached value should be written at runtime. So using populate cache, we can configure the cache values at runtime. Okay. The populate cache policy is designed for writing entries. Okay. Populate cache is writing entries in a short-term general purpose cache, and lookup cache is to reading something from the cache store. So populate cache, using populate cache we can write something, and using lookup cache we can read something. It's used in conjunction with the lookup cache policy and invalidate cache policy for invalidating entries, for caching the response of backend resources. Yeah. So how to do that? Let's see. The following list of elements you can configure on this policy. Okay, so cache key reference you can use, and uh, you can omit this element if you are using included shared cache. Scope is exclusive, and timeout value you have. Okay, source you have, from which source you are taking. Okay, so these things we have under the populate cache policy. Now, let me open a proxy. Open this populate lookup cache example. Um, so okay, so here I have created one simple API proxy with this mock target.apg.net/json, this endpoint. Into the pre-flow I have added one lookup cache. So we have already learned that lookup cache is to reading the entries, and populate cache is to writing the entries. Okay, so using lookup we can read. Using lookup we can read. Okay, so read from where? Cache resource is my cache. Okay, so we are going to read from this cache, my underscore cache. So let's open this cache. Go to duplicate, open a duplicate window. Go to, like the same way we created kvm, the same way we are going to create a cache. Go to admin, environment, cache. So this is deployed in test, so you have to deploy your cache as well in the test environment. Here you can see my cache. Okay, so I have already created my cache store. It will expire after 5 minutes. Okay, let me clear this cache once. My cache was cleared. Now go to this this proxy. Here I have added one lookup cache. Lookup cache resource is my cache. Scope is exclusive, assigned to flowware token. So this is reading the entries. That means whatever store we have inside the cache policy, that will be read by lookup cache. Okay, and using populate cache we are going to write the entries. Next, what is happening? Cache key. Cache key is key fragment is token. That means based on the token value, it will check the value, what value I'm going to pass. Okay, so go to the assign message policy. Next policy, assign message. What is happening here? Here you can see assign variable flowware token. Name is flowware token, and the value and template I am taking timestamp. Client received start timestamp. This is one type of flow variable. So we are just testing it whether our cache is properly stored or not. Okay. So this value, okay, this template timestamp will be stored under this flowware token. Okay. So from where we are getting this? We are getting this from the flow variable. Okay, and type is requests. That's it. Now here you can see flowware token. So this is my flowware token where I'm assigning my cache resource. Okay, and in the next policy we are adding timestamp into the flowware token. Okay, now go to the next policy, the populate cache. That means writing something. So cache resource is my cache, and scope is exclusive. Cache key is key fragment token. Fine, and our expiry settings timeout in second is 60 milliseconds. Okay, 60 seconds. Timeout in second 60 seconds, and source is flowware token. That means into the flow-aware token, we are writing something. If we are writing something, that will be stored, okay, into the cache. So what is my cache store? Cache resource is my cache. So that means first time when we are sending something, my cache will be stored with that request, okay. So the second time it will look up means it will reading from my cache, okay, that what data is there inside it, and it will store the data inside the flowware token, okay. And the assign message policy, under that flowware token, it will be rewrite with the timestamp value, okay. So let's see, let me send this request, then it will be more clear. So let me go to trace and start the trace, copy this and send a request. So we got success response, and let's see one by one. So here request you have sent, and here in the lookup cache it is reading from the reading from the flowware, okay. Cache hit false, cache failed false, that means cache did not fail. And this is my organization name underscore my cache, and it will assign to flowware underscore token, okay. So let's see the assign message policy. Here we can see client received start timestamp is this, okay. So this is my client received timestamp, and under the flowware underscore token we are having timestamp, okay. This timestamp we are storing flowware token, and the flowware token we are going to writing, okay. So inside the flowware token we are going to writing the timestamp, okay. So inside the flowware token we have written the timestamp value, okay. Let me check the flowware token here. Send this again. So let's go to trace and what is my policy name? Flowware underscore token is the cache store. Yeah. Okay. Just a moment, I'm getting one call. Yes. So so what we did, we have we have used a lookup cache, we have used a populate cache. Inside that we have captured one timestamp, okay, and that timestamp we are storing inside client received timestamp, okay. So we have stored that inside a flowware underscore token inside that cache store, yeah. So here we can see lookup cache assigned to flowback token. Yeah. So or lookup cache that means we are reading something. Okay. So that is assigned to flowware cache. Yeah. So cache name is this test my cache. Okay, fine. Now yes. Cache entry. Let me clear this cache and now I can send this request. Okay. Yeah, I'm just trying to find the um, where it is written. Writing. Okay, here it is. Flowware underscore token. So this is my cache resource. We have given the name. So under this only our timestamp is written. So that means it is writing the value uh, inside the variable. Okay, so that's it from this look populate cache. Yeah. Uh, we have another policy called invalidate cache. Yeah. So how to use that invalidate cache? Okay. We have prefix, key fragment, and cache context. Yeah, application that added to the entry proxy for which data was checked. Okay, let me check some example. Okay. Let me go to my proxy and add invalidate cache. And key fragment reference we have to give. Let me give a key fragment reference. This okay. Key reference is request URL string. Okay. Cache key. Cache resource scope is exclusive. Proxy name is default. Target name is default. Or child interest is false. So we are keeping it as it is. Let me check. Hmm. what is the proxy name? Application that added the entry. Application that added the entry. Okay, fine. And target net endpoint for which data was cached. Proxy name, variable name proxy for which data was cached. Okay, fine. So let me do one thing. First, let me call this API once. Okay. So I have added one invalidate cache, so it will store the data, but again it will invalidate it. Okay. Invalid cache resource reference and step definition invalid cache from context. Sample cache context revision API box. Sample cache with reorganization reference and step definition invalidate cache. Invalid cache resource reference. Okay, invalid cache resource reference. So what is the cache resource reference I have given? Cache resource reference I have not given anything. So go to the cache resource. Go there. Cache resource. Let me give this. Okay, my cache only. Okay. Yeah. It got saved. Start the. Oh, it is not deployed yet. Deploy and test. So I have added this and it is deployed in test. Let me start the trace and copy this URL and let's see. Open Postman. Okay, paste it and send this request or send ID is equal to 1. So we have send ID is equal to 1. Go to trace and check what happens. So here you can see we have our response cache policy, and after that we have request URI and we are invalidating it. Okay, so let's call this proxy once again. So yep. Okay, so we have captured the cache resource, and here we can see the response time is reduced to 3 milliseconds from 148 milliseconds. Okay, and now if you go to the invalidate cache policy, so you won't be able to see the invalidate cache policy because it is not reaching to the invalidate cache policy at all, because it is returning the response from the cache itself. Now let me do one thing. We are going to put the invalidate cache policy before the response cache. Okay, let's see what happens then. Let's send this. We got success response, and here you can see our invalidate cache policy works fine. Okay, so it is invalidating from the request URI. Okay, that means it is invalidating the cache store, and it is reaching to the cache itself. Okay, from the cache itself it is returning the response. Now if we go to the other proxy, popular lookup cache. Just a moment, let me open validate cache policy. Just a moment, I'm just checking. The fragment references a period of cache ID, and scope is application, and value source lookup cache. Cache. It will look up ascending request log error. Popular cache, cache key, Apigee cache ID, popular cache application, expiry time, timeout in sequences, 30 expiry settings. 30 source is cache where ASCII. Okay, so they are trying to invalidate the cache. Okay, so we have to wait for some time to invalidate the cache. Okay, okay, fine. So let's try this out. We are using the lookup cache policy here. Just and operate and lookup cache. Go to develop. So invalidate cache would be placed before lookup cache policy. Okay. Here it is mentioned that in order to test, I'm executing the lookup cache policy after the invalidate cache policy. Okay, so lookup cache. So lookup is should be retrieved at runtime. How cache policy should be retrieved or read. Okay, so before reading it, we can use the invalidate cache policy. So there is slightly change into the order of this policy. So first we have to write a populate cache at the beginning, and then we will read it from the lookup cache. Before reading it, what we will do, we will use the invalidate cache policy. Okay, so use the invalidate cache policy here. Use it before the lookup cache. So in this invalidate cache policy, we have to change slightly. Key fragment reference you have to give, and scope should be same. Only the cache key you have to add. Okay, cache key fragment, or cache key should be same. Yeah. What is the cache key we have given? Cache key fragment is token. That's it. Exclusive proxy. Okay, proxy name. Proxy name and target name. Okay, fine. Let me do it. First, we will Right. What is the error? Invalid cache resource reference step definition, contribution. Invalid cache resource reference in invalid cache resource reference. Okay. Cache resource. Okay. Cache resource we forgot to give the cache resource. Take it from another policy. And cache resource is my cache. So I'm going to invalidate my cache. Okay. So we won't be able to see the timestamp into the flowback token. Okay. What we are assigning. Trace. First, let me deploy this. Test. This is deployed. Go to trace. Start trace. And go to Postman. Okay, we got success response. Go to trace. Here you can see populate cache got skipped, and because it is not writing anything and it is not reading anything because we have invalidated. So this in this invalidate cache policy, we can see this is executing properly, and here we can see here you can see the result is true. That means this invalid cache is working fine. You won't be able to see it more than that. And here our flowback token, yeah, so you can see it is not assigned anything. Let me do one thing. Let me add the lookup cache at the beginning, the populate cache at the end. Okay. So we are going to read it first and then write. So the vice versa also we are trying. First we are going to read and then we will write it. Trace, here you can see cache policy. And after that is the assign message policy or timestamp got added and invalidating. We are invalidating it. Means we are deleting it. And this we have our flowback token. Okay. Yep. Yeah, so that's it from this lookup cache and populate cache and invalidate cache, okay, and response cache. So all the cache policies we have covered. Okay. Yeah, so that's it from today's class.